is precipitation. Evaporation, condensation. The last one is your precipitation. Precipitation is nothing but the downfall or falling of condensed liquid. Condensed liquid na meaning enna enoda condensation nadந்து suspension la irukkudiya and the particular drops of water will fall down. Yeah, so these are falling of condensed liquid from clouds to the surface. To the surface primarily due to their increasing weight. Increasing weight and Earth's gravity. So precipitation is nothing but condensed liquid. Condensed liquid na meaning enna evaporation na liquid state to gaseous state. This is what your evaporation is all about. And what about condensation? Condensation is where my gaseous water vapor or vapor in the gaseous form is again converted back into liquid. And this liquid is microscopic in nature, very, very small. 1 micrometer, it can vary up to 50 micrometer. Okay, 1 micrometer to 50 micrometer. This is very, very small. And at this range, it can be suspended. Suspended, na, the air can hold this much weight of your water size or nature of your water vapor. When the size of water vapor increases, meaning to 75 and 100 micrometers, illana 1 millimeter and 5 millimeter. In the mari, when they grow in size, that liquid will gain weight, and that weight is being attracted by Earth's gravity. Therefore, they will fall from the clouds to the Earth's surface. So when clouds are formed, the condensation liquid, then what would happen? It will fall. So suspension la irukumbodhu appo liquid state la da irukum, but that liquids are so much microscopic. Hundreds and thousands of microscopic water droplets would be there, and they would grow in size, and when they grow bigger, no more the cloud can hold back. So they will fall on the ground due to the attraction of Earth's gravity. And this falling nature is known as precipitation. And precipitation can primarily happen. The forms of precipitation, precipitation can primarily happen in 2 different forms. One is in the solid form. The other one is in a liquid form. Okay. When does the rainfall or when does precipitation occur in solid form? When dew point is below 0 degree Celsius. When the dew point is below 0 degree Celsius, the precipitation would be in your solid form. Example, in the form of snow, the form of sleet, the form of hail. These are all examples of precipitation in the form of solid. Liquid appo, liquid abingiradhu illa liquid state le appo precipitation nadakona when the dew point is above 0 degree Celsius, then the rain will occur or the precipitation will occur in the form of liquid. Example, drizzle, rain. Okay, this concept is dew point. We already know dew point and 0 degree idoda comparison da pandrom illa. When the dew point temperature is greater than 0 degree Celsius, adu enna liquid. And when the dew point is less than 0 degrees Celsius, it is my solid. So I'm going to rephrase this. This is the definition, but when we rephrase, dew point dew point is the temperature at which relative humidity becomes 100%, or dew point is the temperature at which the air becomes saturated. Yeah, so when saturation occurs, dew point oda innuru phrase enna saturation of air. That is when relative humidity equals 100%. So when saturation happens below freezing point, 0 degree Celsius is normal, general water oda freezing point enadhu 0 degree. Appo water oda freezing point temperature vida and the air oda saturation ரொம்ப கம்மி temperaturesல நடக்குது, sub-zero temperaturesல நடந்ததுன்னா, then the precipitation would be in which state? The precipitation would be in the solid state. ஏன்னா water molecules in the air would have frozen down sub-zero condition க்கு போகும்போது. So freezing point விட, that is your 0 degree Celsius. Saturation is referred with the term of dew point, the temperature at which saturation occurs. So the temperature at which saturation occurs is your dew point. Appo இந்த மாதிரி அதை rephrase பண்ணலாம். When saturation of the air occurs below freezing point, the nature of precipitation would be in the solid state. Vice versa, when saturation happens above your freezing point, then the nature of precipitation would be in the liquid state, predominantly drizzle and rain. Okay, so this is very common, very simple. Similar to your clouds, what we're going to do? We're going to divide the types of different forms of precipitation. Okay, as per the International Cloud Atlas. Okay, International Cloud Atlas. Just give me a number. How many types of precipitation irukkalam? Types. That is solid like snow, sleet, hail, rain, drizzle nalla paakala. These are all different forms of precipitation. So in the types of precipitation, எத்தனை இருக்கலாம்? Give me some number. I'm trying to make it quite interactive. நீங்கலாம் தூங்கிர கூடாதுங்கனால. So it is approximately 50 types ma. And obviously we're not going to learn all 50. We're going to focus on the most important 5 or 6 types. Okay, so you're getting me? So forms of precipitation pathilla, then we will study 2 theories. How rainfall occurs. அப்படின்னு சொல்லிட்டு 2 theories இருக்கு. First we'll make the simple one. Okay, so types la first give the heading. Table la first one, we're going to write the type. State na solid state or liquid state. Okay, state, size, description. So this is going to be a tabulation. The first one is mist, and state is liquid. The state is liquid, and the size varies from 0. Approximation 0.005 mm to 0.05 mm. Size or dia of that particular water body, water droplet would be 0.005 mm. Mm na millimeters. To 0.5 mm. So this is your approximate size. And description. Write down the description. These are associated with the stratus clouds. Drizzle, mist is associated with the stratus clouds. Okay. Droplets are same. Droplets are large enough to be felt. Droplets are large enough to be felt when air is moving. When air is moving. One meter per second. When air is moving 1 meter per second. Meaning, if there is stationary, drizzle is falling on us, there is very, very little relevance. We can feel that I'm standing in rain. மழையில நிக்கிற மாதிரியே தெரியாது ஆனா will become wet. என்ன சொல்றேன்னு புரியுது அந்த மாதிரியான very minute small droplets. But when the wind is in action, whenever stable இல்லாம very gusty wind ஓட drizzle இருந்தா we can feel the rain. Okay, அந்த மாதிரியான small minute raindrops is my mist. So mist இன்றது feel பண்ண மாட்டோம். So எப்போ feel ஆகும்? Only when moving air at a speed of 1 meter per second. இந்த மாதிரி ஒரு speed இருந்தாதான் we will feel the mist. Okay. So the next one is drizzle. Drizzle again liquid. Drizzle is again liquid. The size varies from less than 0.5 mm. Okay, less than 0.5 mm. Description is that these are small uniform drops. Small uniform drops. Small uniform drops that fall from stratus clouds. Continuation. They generally last for several hours. So they are small uniform drops of rain, mostly associated with the stratus clouds, and they last for generally several hours. The third important is your rain. What we call as your rainfall. Rainfall, which state is again your liquid state. Liquid solid definition basis based on the dew point temperature. Liquid and the rain varies from 0.5 mm to 5 mm. Diameter of the rainfall. It can vary from 5 mm, 0.5 mm to 5 mm. Description. Generally produced by rainfall, it is generally produced by nimbostratus or cumulonimbus clouds. Generally produced by nimbostratus or cumulonimbus clouds. Next point, when heavy means heavy rainfall. When heavy, size can be highly variable. From place to place. Size can be highly variable from place to place. So these are all what? These are all important liquid form of precipitation. Okay. Next we're going to see 5 of important precipitation in the solid form. The first important one is your sleet. And the dia, it can vary from 0.5 mm to 5 mm. description. Sleet. These are small spherical to lumpy ice particles. These are small spherical to lumpy ice particles. Yeah, Eldrina, I'm not sure whether my sound is audible. My audio, I'm terribly affected with throat infection, therefore. Okay, so small spherical to lumpy ice particles that form when raindrops freeze. Form when raindrops freeze. Okay, so whenever this is my clouds and rainfall is being produced, when this rainfall is suddenly encountered with the cold air before reaching the surface. So what would happen to the falling rain? After crossing the cold air, the rain becomes frozen. Why? Because the cold air would induce minus temperature, or it will lower down the water droplets, making the water in a solid state. So fall ஆகும்போது எந்த மாதிரி தான் இருக்கும்? Water மாதிரி தான் இருக்கும். Liquids formatல தான் இருக்கும். But after crossing the cold air, it would reach the ground in the solid state. Such type of precipitation is known as sleet. Okay, so I'm going to repeat. Small spherical to lumpy ice particles that form when raindrops freeze while falling through a layer of sub-freezing air. Falling through a layer of sub-freezing air. Okay, next one is glaze. The next important precipitation form is your glaze.
Ma'am. Ma'am.
Solid, and the size varies from
Ma'am.
1 mm to 2 centimeter thick. 1 mm to 2 centimeter thick. So larger form of rainfall is your glaze. Okay, glaze order description. Yes, ma.
I'm sorry to bug.
Yes, ma. Sure, ma. You can go. You can rewind பண்ணி பார்க்க முடியும் தானே? முடியாதா? Okay then. So you will be having a 10 minutes break now. Okay. So I'll continue after 10 minutes. Or probably I will write down the chart. I'll make it easy for you to copy down. Okay. Fine. Children, say something. Already. Fine, pa. Take a 10 minutes break. We'll resume the class after 10 minutes. Okay, I'm gonna resume the class. Am I audible? Is the screen visible? Am I audible? Is the screen visible? Okay. So we'll continue where we stopped. We're discussing about the different types of precipitation, different forms of precipitation, and in that we were discussing the solid type. So solid, first one is your sleet, second one is your glaze. Okay, so glaze. Glaze is again solid composition ranging from 1 mm to 2 centimeter thick. Okay, 1 mm to 2 centimeter thick. And the description where they are formed. Write on this, I'll explain. Okay, produced when supercooled raindrops. Produced when supercooled raindrops freeze on contact with the solid objects. So glaze is produced when supercooled raindrops freeze on contact with the solid objects. And they are relatively more dangerous than your sleet. Sleet is a dangerous phenomena because of their bigger size and their nature. Right? So they can seriously damage trees and power lines. They can seriously damage trees and power lines. Okay. The next one is rime. R-I-M-E, rime. So when does rime occur? Rime is again a solid precipitation of variable accumulations. Accumulations mean it can be sometimes a mixture of liquid and solid, and the sizes can vary from very minute to bigger ice particles. Okay, the size can vary. Another variable accumulations. Okay. Description. How do we describe? They are deposits. They are deposits usually consisting of ice feather. They are deposits usually consisting of ice feather pointing into the wind. So wind action ice droplets would freeze. So if this is my direction of wind, and this is again a cold air, assume this is in the region mid latitudes. And a solid rainfall or snowfall is very typical of mid latitudes and polar regions. Appo cold air if this is my raindrop, the raindrop would be shaped by my wind action, and sometimes these raindrops or pellets would have a pointed end. So in the rhymes, this is also very common in mid-latitude countries, but very, very rare in tropical countries like India. Right? So write down the description. These are deposits usually consisting of ice feather pointing into the wind. The delicate frost-like accumulation form as supercooled cloud or fog deposits. Supercooled cloud or fog droplets encounter objects and freeze on contact. Encounter objects and freeze on contact. The supercooled underline pandrena. When we talk about the theory, I'll explain what you mean by supercooled cloud. Okay, supercooled liquid, supercooled clouds. We'll discuss that. First, you write down the descriptions. Okay. So repeat again. I read through the statements for rime. Rime is the deposits usually consisting of ice feathers pointing into the wind. These delicate frost-like accumulations form as supercooled cloud or fog deposits. Droplets encounter objects and freeze on contact. Next one is snow. Okay, so snow is again solid object. The size, approximate size, it can vary from 1 mm to 2 centimeters thick. Okay, 1 mm is very minute and 2 centimeters thick. And how they are formed? They are produced in supercooled clouds. They are produced in supercooled clouds where water vapor is deposited as ice crystals. They are produced in supercooled clouds where water vapor is deposited as ice crystals. that remain frozen during their descent. They remain frozen during their descent. So cloud liye enna nadakudhu? Cloud liye this water droplets would freeze. And even after their fall, they would remain in the same state of nature. That would be solid nature. This is your snowfall. Next one is your hail. Hail or hailstone. Hail, illana hailstone, illa hailstone. Because of their dangerous nature, hailstone appdin kuda solluvaanga. So hail is the common name. Hail, solid nature, it can vary from 5 mm to 10 centimeters or even larger. Based on the climatic conditions, if the convection is more, the ice particle can grow in size, bigger and bigger. Idu vandu onion ice appdin kuda refer பண்ணுவாங்க, nicknamed as onion ice, similar to an onion. This ice will have layers and layers of ice accumulated over time. Okay, that's how they grow in size. So idu onion ice appdin kuda refer பண்ணுவாங்க, nickname da, not officially it is being referred. So going back to the description, how hails are formed. These are the precipitation in the form of hard rounded pellets. Hard, munadila soft ngra mari or term paathirupom. These are very very hard. Okay, they are hard rounded pellets or irregular lumps of ice. Irregular lumps of ice. They are produced in large convective cumulonimbus clouds. The convective term romba important. Enna meaning na, already cumulonimbus clouds are towering clouds, meaning they have larger vertical extent. Within the clouds are formed due to ascendance of air and after condensation and all. So within the cloud, what will happen? Within the cloud, there is a strong ascendance and descendance of air. This updraft, downdraft nu kuda solluvaanga. Updraft, downdraft is the convection that is ascending and descending. Warm air and cold air, relatively warm and cold air within the cloud. So cloud kulliye, because of their large vertical extent, கீழ இருக்கக்கூடிய air cold ஆ இருக்கலாம், relatively warm ஆ இருக்கலாம், மேல இருக்கக்கூடிய air cold ஆ இருக்கலாம். So their thermal contrast is happening within the clouds and convection happens. And as a result of repeated convection, condensation நடந்ததால clouds form ஆகுது. So clouds லயுமே ascendance நடந்தா further இங்க இருக்கக்கூடிய air திரும்ப cool down ஆகிட்டே இருக்கும் repeatedly. So the convection is happening multiple times within the cloud, which makes the ice particles harden themselves by making consecutive layers of ice above the same droplet. Okay, so I'm going to repeat the last statement here. Produced in large convective cumulonimbus clouds where frozen ice particles and supercooled water, frozen ice particles and supercooled water coexist. So the clouds will have ice particle as well as supercooled liquid. Supercooled liquid meaning enna, sub-zero conditions vanda peragum, adayithu normal or water eppo freeze agum 0 degree. Okay, so this you need to take down. Supercooled liquid அப்படிங்கிறது water in the liquid state even after reaching and remaining below 0 degrees Celsius or below freezing point. Meaning ஒரு water இல்லனா any object அதோட freezing point க்கு அப்புறமேட்டு temperature down ஆனா என்ன ஆகும் freeze ஆகும். So இப்போ water பொறுத்த வரைக்கும் 0 degree Celsius தான் அதோட freezing pointனா இதுக்கு மேல இருந்தா அது water ஆகும், இதுக்கு கீழ இருந்தா அது solid ஆகவும் இருக்கணும். இல்லையா solidனா water பொறுத்த வரைக்கும் ice. ஆனா what would happen even after the water reaching the sub-zero conditions, the state of water does not change. It will remain in the liquid factor and a slight disturbance to the liquid would instantly change the liquid to the solid state. Okay, instantly changes. ஒரு disturbance நடந்தா இந்த liquid stateல இருந்து solid stateக்கு அப்பதான் மாறும். அது வரைக்கும் அந்த வாட்டர் கூல் ஆகிட்டே இருக்கும். நெகட்டிவ் கண்டிஷன்ஸ் வந்ததுக்கு அப்புறமேட்டையும் வாட்டர் அதோட லிக்விட் ஸ்டேட்லயே மெயின்டைன் ஆகும். வாட்டர் இன் தி லிக்விட் ஸ்டேட். இந்த மாதிரி ப்ராப்பர்ட்டியை எக்ஸிபிட் பண்ணக்கூடிய வாட்டரை தான் சூப்பர் கூல்டு லிக்விட்னு சொல்லுவாங்க.